Consider the following frequency distribution of the heights of 60 students of a class. The sum of the lower limit of the model class and the upper limit of the median class is. So we have the marks distribution given starting from 150 to 180. The first thing about the model class, it is simply the class with the highest frequency, and that will be 150 to 155. Now we have to find the median class. For that we will write the cumulative frequency. I will denote as CF. First one will be same as 15. Next will be 15 plus 13, it will be 28. And then 28 plus 10, 38. 38 plus 8, it is going to be 46. 46 plus 9, it will be 55. And 55 plus 5, it is going to be 60. We can also write summation of all this value is going to come as 60. This is going to be same as this. Therefore, we have n as 60, or n by 2, which is the midpoint, will be 30. So where will be the 30th value? 30th value will be between 28 and 38. Therefore 160 to 165 will be the median class. Now the question asked is that sum of the lower limit of the model class and the upper limit of the median class. So that will be 150 plus 165. And that value will come to be 315. That is option B. If xi's are the midpoints of the class intervals of grouped data, fi's are the corresponding frequencies, and x bar is the mean, then fi xi minus x bar is equal to, and we have 4 options. What I understand is that the question is not clearly given. Okay, when I try to solve this, I personally feel that there is some issue with the way the question is represented. In the question, we are asked to find fi xi minus x bar. Now there is no doubt about fi xi. It is a summation of all the fi xi values. Okay, and x bar is the mean. But what will be the value together? That we cannot find, right, without the actual values. Let's write the equation for the mean, that is x bar, and we will get x bar equal to summation fi xi divided by summation fi. Okay, or I can write summation fi multiplied by x bar is equal to summation fi xi. Okay, so further I can write 0 is equal to, by rearranging the terms, summation fi xi minus summation fi x bar, or 0 is equal to, removing the summation notation, I can simply write fi xi minus fi x bar. You can see that fi xi minus fi x bar will come to be 0. In the question we are asked fi xi minus x bar. Now what will this value come to be? I simply do not know. Okay, if the question was fi xi minus fi x bar, then it will be 0. If you look at the answer provided by CBSE for this question, it is given as 0. So I think there is a printing mistake where they have missed this fi in this question. Okay, I think what they meant is fi xi minus fi x bar, and they missed this fi x bar. In the formula, x bar equal to a plus h into fi ui divided by fi, for finding the mean of the grouped frequency distribution, ui is given as, it's a straightforward problem. We are asked to find the value of ui, that means this is coming from step deviation method, and ui will be simply equal to xi minus a by h, and that will be option C. The abscissa of the point of the intersection of the less than type and of more than type cumulative frequency curves of a grouped data gives its, we have 4 options: mean, medium, mode, and all of the data. To solve this, what I have done is that I have used data already available in the CBSE textbook, that is in chapter statistics, particularly table 13.13 and table 13.14. So I have taken values from these two tables and made a plot. Okay, because making this plot is very important for all of us to have a feeling of, or to understand what is this problem actually. So this is the plot. Okay, again the values are from the table 13.13 and 13.14. Okay, you can refer to these tables for these data points. Okay, so the points in the rose color that you see here, that is the less than type, and the points in the blue color is the more than type. Okay, I will not go into the details of how this is plotted, but I will give few examples. Let's say we are plotting the first point from the less than type frequency curve. So the first point is marks obtained less than 10. Okay, we have 5 students, right? So less than 10 is this area and we have 5 students. Okay, and the last point is marks obtained less than 100. We have 53 students and that is this point. Okay, if we show here, will come somewhere around 53. Fine. And from the more than type, you can see that more than or equal to 0, we have 53 students. So more than or equal to 0, we have 53 students. And more than or equal to 90, we have 8 students. Okay, that is this point. That will be somewhere here, 8. Now in the question, it is asked the point of intersection of the less than type and the more than type cumulative frequency curve. So what does this mean? We have to find a line which will pass through all these points. Okay, and again for the less than type, we have to find a line that will pass through this point, and finding this line or a curve that will pass through this point is a different task. I will not go into the details of how it can be done, but there are many ways to do it, and for a student of class 9, that is not required for all of you to know. In fact, this plotting of this less than type and more than type, this itself is not given in the textbook, but it is asked as a question in Exemplar, so we are learning it just to have an understanding of how statistics could be depicted in different ways. Okay, and this kind of plotting is generally called as a ogive. Okay, now what I will do is that I will show a trend line or a curve that will pass through all these points. Okay, again this is not required for all of you to learn. This is beyond your syllabus. At some point in your life, if you are learning mathematics, you will learn how to do this. Okay, now I have joined all the data points using a curve. Okay, so the curve almost passed through all the data points. Okay, now what is the point of intersection of the two curves? You can see the point of intersection of the two curves is somewhere here, right? At this particular point, the two curves will meet. And what will be the corresponding marks? Okay, let us find the point. It will come somewhere here, and this value will come to be somewhere around 66.4, which is what you actually calculate in the textbook, right? As I said before, these are data points corresponding to table 13.13 and table 13.14. Okay, and in the textbook this is a solved example, and you will find the medium to come to be around 66.4, and instead of numerically calculating all this point, you can actually plot, both the less than type and more than type, find the intersection point, and you can find what is the median value. Okay, this is finding the value from a visual point of view. Again, you don't have to learn about finding this trend line, that is beyond the syllabus. Therefore, the answer to the given question will be, this is nothing but median. Consider the following frequency distribution. We have a table given and we have to calculate the upper limit of the median class. So the classes are not represented in a continuous fashion. You can see it is coming from 0 to 5, then the next class is 6 to 11, and then 12 to 17. So it is not in a continuous fashion, but it is in a discrete form. So I will rewrite this table once more. Okay, so we have the data given in a tabular form. So the first thing that you can do is that we will find the cumulative frequency. Okay, and that will be, the first value is simply 13. The next is 13 plus 10, it will be 23. Okay, then it will be 23 plus 15, you will get 38. Similarly, 38 plus 8, you will get 46, and then 57. We can also write summation of all the frequency to be 57. Therefore, we have n equal to summation fi is equal to 57. That means the middle value, that is n by 2, will come to be 28.5. Where will this 28.5 lie in this data set? It will be between 23 and 38. Okay, that means it is in this particular class, that is 12 to 17. So the median class is 12 to 17. So the answer will be 17. Is it so? No, the answer is not 17. Why? Because we have not re-represented this class intervals into a continuous form. So when we do that, how it will come? So each of this class is not in the continuous form, right? It is 0 to 5, then it goes from 6 to 11. So how can we re-represent these class intervals into the continuous form? Let us do that here. So when I add and subtract 0.5, I can rewrite all the class intervals in this form, and now it is in a continuous fashion. It is 0 to 5.5, then 5.5 to 11.5, 11.5 to 17.5, and so on. So in this question, we found out that the median class to be 12 to 17. Okay, and in the continuous form, we can see that the class interval will be 11.5 to 17.5. And what is the upper limit of the median class? It will be 17.5. So the answer is 17.5. Therefore, the upper limit of the median class is 17.5. Some of you may have doubt that why I didn't reduce 0.5 from 0. Of course, you can do that. You can write it as minus 0.5. But for the neatness, I didn't do that. We are only looking at positive data points. So I started from 0. Okay. I will go through this problem once more. In the given problem, the class intervals has numbers that are included within the class, right? So 5 is included within this class. 6 and 11 are included within this class. Similarly for all the classes. Okay. What we have to do, we have to make this into a smooth or continuous class interval, and for that what we did, we add and subtract 0.5 from both the extreme limits of the class. Okay, let's say for 6 to 11 class, I add and subtract 0.5 from both the ends. 6 becomes 5.5 and 11 becomes 11.5. Similarly for all the classes. Finally, we can ask one more question. What will be the lower limit of the median class? Lower limit of the median class will be 11.5. For the following distribution, the model classes, so this is in the form of less than type frequency. So what I will do is that I will convert this into the regular frequency distribution. The first thing, the class intervals for marks I can write as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. And correspondingly, I can write the students as, for 0 to 10, it will be simply 3 students. For 10 to 20, how do we calculate? For 10 to 20, I can calculate using below 20 and below 10. Or 12 minus 3, 9. 9 will be the number of students between 10 to 20. Next, for 20 to 30, how many students will be there? It will be 27 minus 12. We will get 15. Then similarly for the next class, I can write 57 minus 27 or 30 students. Similarly, if you do, you will get 18 and 5. Now what is the model class? Model class is the class which has the highest frequency, and that will be 30 to 40. Okay, 30 is the highest frequency and that is corresponding to 30 to 40. Or option C. The time in seconds taken by 150 athletes to run a 110-meter hurdle race are tabulated below. So we have the table given. and it shows class intervals representing different times taken to complete this hurdle race. The number of athletes who completed the race in less than 14.6 seconds is. This is what we have to find. What we have to do is that we have to convert this frequency distribution into a less than type. Let's do that. So first I will write all the less than type and the corresponding cumulative frequency. So we can start from up to 14. Now what will be the corresponding cumulative frequency? Up to 14 it will be simply 2. Okay. Up to 14.2 it will be 2 plus 4 and that will be 6. Up to 14.4, okay, we have to add 2 plus 4 plus 5, that will come to be 11. Similarly, I will get 82, 130. How do I calculate up to 15? I have to calculate all the data points. So that will be 2 plus 4 plus 5 plus 71 plus 48 plus 20. Okay, you will get 150. In the question we are asked the number of athletes who completed the race in less than 14.6 seconds and that will be 82 athletes. Fine. Let us ask one more question. What will be the number of athletes who took more than 14.6 athletes to complete the race? Let us ask one more question. What will be the number of athletes who took more than 14.6 to complete the race? We can easily calculate this, right? What we have to do? We have to do 150 minus 82. You will get the answer for this particular question. So that is 150 minus 82 will come 68. That means 68 athletes took more than 14.6 to complete the race. Another way to do is that to find the number of athletes who took more than 14.6 seconds, we have to simply add these two data points, that is 48 plus 20. You will also get the same 68. An event is very unlikely to happen. Its probability is close to. So it is said that the event is very unlikely to happen. Okay, let the event be denoted as A. If the event cannot occur, then its probability will be P of A bar equal to 0. What we have to do in this problem is that we have to check which option is closest to 0, and that will be option A, 0.0001. Option A, 0.001 is the closest to 0 and it is the answer. Next question. The probability expressed as a percentage of a particular occurrence can never be. The four options are less than 100, less than 0, greater than 1 and anything but a whole. We know that probability of an event can range from 0 to 1. Now, if we express this in terms of percentage, it can range from 0% to 100%. Now we will go through the options. Option A is less than 100 and that is possible, right? Option B is less than 0 and that is not possible. Option C is greater than 1, that is possible. And option D is anything but a whole. It is also a possible value. Option B less than 0 is the answer. Why? Because this is impossible. Why? Because probability can never be negative. The probability that a non-leap year selected at random will contain 53 Sundays. That is, if we select a non-leap year at random, okay, what is the probability that it will have 53 Sundays in it? In a non-leap year, we will have 365 days. So the number of weeks in a non-leap year we can calculate as 365 divided by 17. You calculate, you will get something around 52.14, or we can write the same answer as 52 weeks plus 1 day. So in 365 days, we will have 52 complete weeks, okay, plus 1 day. So in 52 weeks, we definitely have 52 Sundays. Fine. In 52 weeks, we will definitely have 52 Sundays. Now the question is about this 1 day. What could be this day? It can be any of the 7 days in a week. So we have 1 day out of 365 days, for which we do not know whether it will be a Sunday, Monday, Tuesday or whatever. Okay. So probability of this 1 day to be a Sunday will be, how many possibilities are there for this 1 day? We have 7 possibilities, right? It could be Sunday, Monday, Tuesday all the way up till Saturday. So there are 7 possibilities, and what we need is Sunday. So this probability will be nothing but 1 by 7. Why? We have 7 possibilities, that is all the 7 days of the week, and what we need is, we need a Sunday, and we have only one Sunday per week, so the overall probability will be 1 by 7. So the answer is option A. Let us ask one more problem from the same question. That is, what if a leap year is selected at random instead of a non-leap year? We are selecting a leap year at random. What will be the probability that it will contain 53 Sundays? How do we do it? Out of 366 days, we can see that 366 divided by 7, if you do, what we get is 52 weeks plus 2 days. Again, in this 52 weeks, we have 52 Sundays, and that is something we are sure about. The question here will be, what will happen in these 2 days? We have to see the probability of a 7 occurring in this 2 days. Okay, what are the probable events for this 2 days? It could be, okay, it can be a Sunday, Monday, okay, it can be a Monday, Tuesday, and so on. It can be a Saturday, Sunday. So how many possibilities are there? We will have 7 possibilities. Okay, we will have 7 possibilities for this 2 days, and out of these 7 possibilities, how many possibilities will have a Sunday? It will be only within Sunday, Monday and Saturday, Sunday. So in Sunday, Monday and Saturday, Sunday, we will have Sunday, right? So the probability will be 2 by 7. Once more, why 7? Because we have 7 possibilities, right? 7 possibilities for this 2 days. And why 2 here? Out of the 7 possibilities, 2 have Sundays in it, right? This is this 2. The probability of getting a bad egg in a lot of 400 is 0.035. The number of bad eggs in the lot is. So we can write the total number of eggs is given as 400. It is also given that probability of a bad egg will be, we can write as number of bad eggs divided by total number of eggs, or the probability of a bad egg is given as 0.035 is equal to number of bad eggs divided by number of total eggs is 400. Therefore, number of bad eggs we can write as 400 into 0.035 or 14. So the answer will be option B, 14. A girl calculates that the probability of her winning the first prize in a lottery is 0.08. If 6,000 tickets are sold, how many tickets has she bought? 4 options are given. How do we solve this? I will go step by step, okay? If I randomly buy 1 ticket, what will be the probability? Let's say if the girl buys one ticket, okay, randomly, then the probability of winning will be P is equal to 1 by 6,000, right? That is, there are 6,000 possibilities. We have 6,000 tickets or 6,000 possibilities, and out of which only one will be a winning ticket, right? Now if she is going to randomly select one ticket from 6,000, her probability will be 1 by 6,000. If you have some doubt, continue to listen, okay? Let's say the girl buys all the 6,000 tickets, okay? So she has bought all the tickets. Then her probability of winning will be P is equal to 6,000 by 6,000. Why? There are 6,000 tickets available and she has bought all the 6,000 tickets, right? So definitely she is going to win the lottery. So 100% definitely she is going to win the lottery. Now it is given that her probability of winning is 0.08. Okay, that means 0.08 is equal to number of tickets she bought divided by total number of tickets, or 6,000. So we will get the number of tickets the girl bought is equal to 6,000 into 0.08 or 480. So the answer is 480 or option C. A school has 5 houses A, B, C, D and E. A class has 23 students. Okay, 4 are from house A, 8 from house B, 5 from house C, 2 from house D and the rest from house E. A single student is selected at random to be the class monitor. The probability that the selected student is not from A, B and C is, in this problem what we have to do is that we have to find the probability that the selected student is not from A, B and C. That means the student can be from house D or house E. Once more, the probability that the selected student is not from A, B and C, or we can say that the selected student can be from house D or house E. Okay, so what will be the probability? That is, probability of a student can be from house D or house E will be total number of students in house D plus house E divided by the total number of students across all the houses. So the probability will be the number of students in class D and class E divided by the total number of students, and that will be, in class D we have 2 students plus in class E we will have 4 students. It is a basic arithmetic, you can calculate from the question. And in the entire school we have 23 students, nothing but 6 by 23. So the answer is option B, 6 by 23.